Hi, this is Chris, and we are taking a look at our first few questions here in Section 3 of SAT Practice Test 4. And I want to point out something about this section as a whole, because a lot of students I work with say that they find this section to be rather difficult, and I agree with that. I don't think there are as many freebies or gimmies early on in this section as you find in some of the other math sections that you'll come across, where the question difficulty does go from easy to hard, but even these easy ones have some challenge to them. But what I will say is on test day, if you have that experience, even if you're looking at the first question, which, again, in theory should be rather easy, and you're finding the first one a little bit tough, don't worry about it for two reasons. One is that that's the whole point of a standardized test. It's scaled according to the performance of test takers, so that a more difficult test, the good news is sometimes we'll have a more generous scale. So if you're doing practice, if anything, you actually don't mind seeing some slightly more difficult questions, because that's going to benefit you as the hardworking student that you are who's doing the right kind of practice. And it's going to benefit you because if the question is what's 2 plus 2, then almost everybody is going to get that one right. But if the question is a little bit more challenging, only the students and test takers who are really putting in the effort in their studying are going to see the benefit, because they're going to have a better chance of answering some of those more difficult questions. So in a weird way, you should be rooting for the test to be a little bit more difficult, because that's going to give you, as a test taker who's willing to put in the practice, a little bit more of an advantage. So now let's go ahead and dive into these questions. For question 1, which of the following expressions is equal to 0 for some value of x? So basically, they're saying which of these could be 0. And for this, if we try to solve for absolute value, so before we do anything, we still have to isolate the absolute value, just the same way you would try to isolate a variable. So here, for a, we would add 1 to the other side. This would look like absolute value x minus 1 equals positive 1. B will be absolute value of x plus 1 equals a negative 1 when we subtract that 1 from the other side. C would give us the absolute value of 1 minus x equals negative 1, and D will give us the absolute value of x minus 1 equals negative 1. Now we could try to split all of these up and do the positive and negative versions of these absolute values for each. However, in this case, we might notice that in terms of what these are equal to, and if we catch this, this is hard to catch, but if we catch this, this is why it's question 1, because it's actually not that hard if we happen to have a keen eye for this. But here, this absolute value expression is equal to a positive result, and all three of these absolute value expressions are equal to a negative result. And hopefully we know that for absolute value, your absolute value is going to only give you a positive result. You can't have an absolute value expression that's equal to a negative. So we can eliminate answer choices B, C, and D, and we don't have to find all of the values of x. Remember, they just want to know which of these could work for some value of x, which means that answer choice A here is the only one that could even possibly be true. So we can pick A and move on to question 2. Here in question 2, it says in the function above, b is a constant. If f of 6 equals 7, then what is the value of f of negative 2? So whenever you have a function, when they replace the x value for your function with a number, then we're just going to plug that in the expression anywhere that we see that corresponding x. So here, f of 6 would be the equivalent of saying 3/2 times 6 and then plus b. So we're just plugging this 6 in place of x in this function. And then now, they tell us that that is equal to 7, right? So we can try to solve 3/2 times 6. If you multiply 3 times 6, you get 18, and divide by 2, that would be 9, plus b equals 7, which would give us that b equals negative 2 when we subtract 9 from the other side. So now the question's asking for f of negative 2. So in this scenario, we're going to plug in a negative 2 in place of those x's. And luckily, in our previous step, we found the value of b, so we can plug that in as well. here we're going to plug in a -2 in place of b. So this would be 3/2 times -2 and then plus a -2. And let's see if we can simplify that. So here, 3 times -2 would be -6 over 2 is -3. And then minus 2, that would give us -5 as our final result. So just remember, when you're dealing with functions, no matter how many steps there are, or how many times you have to do it, whatever value they give you here, you're going to take that value and plug it in for x to solve. Now up next, we're going to take a look at question 3. So here we see two equations, and it says if xy is the solution to the system of equations above, what is the value of y? So this looks a little bit more funky than a typical system of equations. Let's see if we could rewrite this so that it looks a little bit easier to work with for each step. So for the first equation that they give us, x over y equals 6, if we clean that up a little bit, we could get rid of that denominator by multiplying both sides by y. And if we do that, then we're going to be left with x equals 6y, which again, it's mathematically equivalent, but it just looks a little cleaner, a little easier for us to process. And for the second equation given, we have a 4 in front of that parentheses. Let's distribute that to each term within that parentheses so that we have 4y plus 4 equals x. Again, we're just trying to display these in ways that look a little bit easier to work with and a little bit more like the traditional display that we might be used to visually. And here, whenever you're dealing with a system of equations, if they've already isolated a variable for you, then that's great, because we can take whatever that's equal to, in this case the 6y, and plug it in for that variable in the other equation, and that's exactly what we can do here. So here we would have 4y plus 4, and then instead of writing equals x like we had here, we know that x is equivalent to 6y, so we can substitute that in. This is the same thing as saying 4y plus 4 equals 6y. And if we subtract 4y from both sides, we'll be left with 4 equals 2y. Divide by 2 on both sides, and we get y equals 2. Let's double check. What is the value of y is what they're asking for, and that's what we already found. So we can pick answer choice A and move on to question 4. Now in question 4, we have another function, and in this case, instead of putting a number in parentheses here, they put another expression, but we're still going to do the exact same thing as we did in question 2. We're just going to plug that in place of our original x. So when you see that the question's asking for f of -3x, you're still basing it off of this function given. And we're going to have -2 times whatever is in that parentheses, whatever that highlighted part looks like. So this would be -2 times a -3x plus 5. And let's simplify. -2 times -3 is +6, so this will be a +6x plus 5. And that matches up to answer choice B. So you can see here that the math on this is not very complicated. The concept, I think, is a little intimidating because we see x's all over the place, and it's a little bit tougher to figure out what to plug in. But just remember that this step here is always going to be the appropriate step. When you're given a function and then you're asked for the value of that function for a particular input, meaning whatever goes in that parentheses, take whatever's inside that parentheses, substitute it in for x.